We are in section 8.3 of our statistics OER course, where we have introduced hypothesis testing and the null and alternative hypothesis, as well as the 4 possible outcomes for a hypothesis test. And now we want to start doing some kind of math, and for this we will need the distribution for the hypothesis test. In the Introductory Statistics by OpenStax textbook, this is section 9.3, the distribution needed for the hypothesis testing. And remember that we will be collecting a sample, and for that sample we will do some kind of statistical summary, and it will either be a numerical variable, so we will be, let's say, calculating the mean of the sample, or it will be a categorical variable, so let's say we will be calculating the proportion in the sample of those items that satisfy the categorical variable. So we want to refresh our memory on how the mean and the proportion of the sample are distributed. So when we are testing a single population mean, we use the distribution of the sample mean. And the distribution of the sample mean will either be a normal distribution with a mean equal to the mean of the variable and a standard error or standard deviation equal to the standard deviation of the variable divided by the square root of n. Or if we don't know the standard deviation of the population, if we don't know sigma, then the distribution of the sample mean will follow a t-distribution with degrees of freedom equal to n minus 1. The population parameter is mu, and the estimated value or point estimate is the sample mean x bar. When we are doing a hypothesis testing for sample proportion, then we will be testing a single population proportion, and we need the distribution of the population proportion. The distribution of the population proportion is a normal distribution with a mean of p and a standard deviation or standard error for the proportion, the square root of p times 1 minus p divided by n. The population parameter is p, in some textbooks pi, like the Greek letter pi, and the estimated value or point estimate is the proportion of our sample. The notation for that is p hat or p prime, and it will equal to the number of elements in the sample that satisfy the category that we are checking divided by n. Now, when we are using these distributions, we are making certain assumptions. When we perform a hypothesis test of a single population mean mu using the student's t-distribution, this will be called a t-test. We will assume that we don't know the standard deviation of the population. The fundamental assumptions, including that we don't know the standard deviation of the population, are that we will select a simple random sample. So remember all the sampling techniques that we learned, that the sample will come from a population that is approximately normally distributed, and that we don't know the population standard deviation, and we will use the sample standard deviation to estimate the population standard deviation. Now, if your sample size is sufficiently large, a t-test works even if the population is not approximately normally distributed, because the larger your sample size, the more approximately normal the distribution of the sample mean will be. Now, if we have a hypothesis test for a single population mean mu using the normal distribution, this means that we know the population standard deviation or that we have a sufficiently large n. Then this is called the z-test because we will be using a normal distribution. The assumptions are that we have taken a simple random sample from the population is normally distributed or n is sufficiently large, and we know the population standard deviation sigma, which in reality is rarely known. And finally, when we perform a hypothesis test for a single population proportion P, we will assume the normal distribution for the the proportion of the sample, and our assumptions will be that we will have selected a simple random sample using one of the sampling techniques we have learned. We will meet the conditions of a binomial distribution, which is a fixed number of trials. We will ask the question to a certain number of individuals in our sample. We will have two outcomes. We will only ask a question that has a yes or no answer, and they will be independent trials, so the probability of getting a yes answer and a no answer for every one individual in the sample is always the same. To ensure that, we need the shape of the binomial distribution to be similar to the shape of a normal distribution, and that will require that NP is greater than 5 and N times Q is greater than 5, both of those, and also ideally greater than or equal to 10. The binomial distribution of P hat, which is the sample proportion, can be approximated by the normal distribution of the sample proportion, which has a mean of P and a standard deviation of the square root P times Q divided by N.